checking here. Is the control room going to be ready about 10 after? Welcome to the Chesapeake Chapter Dinner Meeting. I'm Gundar Oswald, the Program Director. And this evening we have Rich Dye to talk about the Maryland State Highway System and how he's helping to make it better. Interestingly, we heard some notices from the governor how he's going to make it better, so I guess Rich has got to make it better. And so let's hear what he's got to say. And he said he's going to try to apply some Agile technology to it to make it all easier for us to commute every day. So Rich, go ahead.
Thank you very much. Thank you, Gundar. Thank you, everybody. As Gundar said, my name is Rick Dye. I'm the systems administrator for something called CHART, which is the Coordinated Highways Action Response Team. It's a part of the Maryland Department of Transportation State Highway Administration, and has been in place for over 20 years now, trying to make traveling easier and more reliable for the people of Maryland. Tonight I would like to give a presentation about that system. The first third of the presentation is about that system. The second third of the presentation is about how we are doing this major software development and applying Agile principles to it from the previous very strict waterfall methodology that we were required to use by the Maryland Department of Information Technology. And then finally, the last third of the slide, since y'all are not only fellow geeks like myself, but you're also customers that use my product, as Gundar said, there are a handful of major projects coming up that you've probably been hearing about in the Sun and in the Post. So I want to let you know about some of these projects that are coming up so you can keep an eye out for them and see how they're going to affect you. So the Coordinated Highways Action Response Team, that's how we do our real-world application of transportation systems management and operations in Maryland, which is a big deal these days. When there was a time that the highway department was run by a bunch of civil engineers, it still is, but their job was to design bridges and design roadways and to actually build bridges and roadways and maintain bridges and roadways. But there was a time not that long ago, as a matter of fact, it was a governor that is near and dear to everyone's heart. But Governor Schaefer was very interested in getting people to the Eastern Shore during the summertime because everyone was spending all their time on Route 50. They weren't down there at the Ocean City. They weren't spending money. They were very unhappy, and they were calling him. So he called the state highway administrator at the time and said, what are you going to do to operate these roads better? And the state highway administrator said what you would expect any engineer to say. Well, sir, you know, we design the roads, we build the roads, we maintain the roads. It's really the police that operate the roads. To which the response was, you'll find a better way to operate the roads, or your replacement will find a better way to operate the roads. And Mr. Kassoff understood what that meant, saluted smartly, said, yes, sir. And such was the beginnings of the Office of CHART. So we really focused on monitoring the roadways. That's why you started seeing cameras pop up along roadways and managing incidents. You probably have seen our yellow trucks out there. The yellow trucks, if you ever break down, they will give you gas, they'll change your tires, they'll do a lot of states have things called highway helpers, but ours are actually emergency response vehicles. They actually will go up and help the police make it a safer work zone so the police and firemen are safe, but also maybe open up a little bit of an extra lane that the fire truck maybe would have blocked otherwise. So we try to make sure that we're out there at every incident doing incident management. We try to get the information out to the public. You've seen the big overhead message signs. You've probably, hopefully, been to our website, 511maryland.org. We try to get that information out to the public because, once again, if you can be notified about that incident, you don't get stuck in the backup and become a part of that incident. General traffic management. General traffic management is kind of a harder thing, but computer people like me love it. Traffic management is that thought of, right now, one of the problems with I-95 between Baltimore and Washington is everybody trying to go from Baltimore to Washington gets on I-95. But if we could find a way to put a third of that traffic on US 29, a third of that traffic on I-95, and a third of that traffic on the BW Parkway, now suddenly we could manage the flow a little better. Network engineers have known that for years. That's how we build our computer networks. With cars, it's a little bit harder. Cars don't run through switches and routers that we control. You got to communicate with the people in those cars, hopefully pretty soon with the cars themselves, and try to get them to help you with that problem. On our big overhead message signs over the last several years, you've probably seen travel times, real-time travel times to get from this point to that point. That was really our first attempt at trying to manage traffic. If I can give you a choice to say, to get from Baltimore to Washington, currently on I-95 it's this, on US 29 it's this, on BW Parkway it's this, then you can make a reasonable choice. So that's if I say traffic management, it's us trying to, no incident, we're just trying to manage traffic better. Emergency and weather management, you've all been through our winter storms here. Those in amongst themselves will create havoc you could not believe. And then a way to communicate not only to each other, not only to the public, but also to our devices. So there's a communications division that's a part of the Office of Chart. We fit within the Maryland Department of Transportation, which is set up along the lines of modes of transportation. So the aviation component, mass transit component, Maryland Port, motor vehicle, and state highway, as well as the Transportation Authority, who does all of the toll facilities within the state. They all fall underneath the Maryland Department of Transportation umbrella. Within State Highway Administration, it's set up like you would think it would be set up. There's a part of it that does planning and engineering. It's a lot of what we do. There's a part of it that does administration, HR, IT. But then there's a section that deals with operations. Those are our district offices, maintenance, construction. Office of Chart is one of those operational offices. So that's just to kind of give you an idea of where we fit. I think actually I already covered this. So within Chart, there's 5 divisions. We have the people that actually sit at the computer terminals and try to manage what's happening on the roadways. That's our Traffic Management Center operations. The people that drive the trucks that go out there and actually help you, actually push things off the road, actually do whatever they can to get those roads back open again. There's a systems integration team, that's my team. There's a planning, programming, and development team, because none of this happens until somebody comes up with the idea, somebody writes the idea down, somebody makes sure that there's federal funding approvals, somebody makes sure that everything is in place to keep it going. And then once again, we have that communications division that helps us with all of our field equipment, not only communicating to the field equipment, but maintaining the majority of our field equipment as well. So what do? We have traffic and roadway monitoring, everything from pound 77, if you're ever in trouble on the roadway. If you're in serious trouble, please call 911. But if you just happen to notice a disabled vehicle on the shoulder, or you become a disabled vehicle on the shoulder, if you call pound 77, State Highway actually pays for that. It rings to the closest state police barracks, so they'll know that you're out there, but they'll also dispatch us to come out and try to help you as well. We have our own patrol units that are out there. We work closely with the state police. We have speed sensors out there that are on the side of the road that use radar to try to determine how fast traffic is flowing. They can't tell how fast you're driving because it really doesn't matter to us how fast you're driving. If you're doing 70 and he's doing 20, then he is still probably causing a problem, so it's an average. But that's all we really care about in our world. There's lots of closed-circuit television cameras around the state. That was back when Governor Schaefer got a hold of Administrator Kassoff and said, you really need to do something about this. One of the first things we realized is if we don't know what's happening out there, we really can't do a very good job of responding to it. So over the years, you've probably seen these cameras cropping up on the side of the road. Most of them are ours. Some of them belong to the larger counties, like Montgomery County puts out a lot of their own cameras. We work closely with them because another thing people hate to see is government waste. We would hate to see, here's a Montgomery County camera, here's a state highway camera right next to it. So if they have a camera out there, we pull their feed into our system. If we have a camera out there, they pull our feed into their system. The majority of what you see is ours, but there are quite a few that also belong to the major counties. And then we also have traffic probes out there. The traffic probes is a service that we actually brought in. And over the years, we had those separate sensors up there, the speed detectors. And the good thing about speed detectors are we own them, we maintain them. The bad thing about speed detectors is if I have one here and I have one a half mile up the road, if I know what's going on here and I know what's going on there, I can make some assumptions about what's happening between the two. But that can be a huge assumption if there's a major crash that happens to be 400 feet prior to the next speed sensor. So over the years, we try to come up with what's a better way of determining traffic flow. And we worked with the cellular companies for a while, trying to figure out if we could use cell phones to figure out how people were doing. We actually had a project that went across the Woodrow Wilson Bridge probably 15 years ago to see if we could do that. And it worked okay. It didn't work as well as we wanted it to work, and we really were getting our feet into a new area that we were not that comfortable with, which was tracking people by their cell phone. Even 15 years ago, that was kind of a iffy thing for the state to get into. But in the meantime, several companies cropped up that started doing things like providing a service where you are UPS and you want to know where your trucks are. UPS puts sensors on all their trucks. UPS knows where their trucks are. Well, does UPS want to make some additional money by selling that data to another company? Sure. So another company now has all these probes out there wherever the UPS trucks are. That's probably not enough. Well, this company also went and talked to BMW. A lot of BMWs out there, the newer ones have that same service in them. So there's another company out there that's gathering all this data. Then they start selling that sanitized data to other people that want it. We want it, so rather than the state taking your money and putting equipment out there that we have to design, we have to build, we have to put comm to, we have to maintain, if I can buy that same level of service from a company, and this company is providing me with only sanitized data that is not individual raw data, but is merged over periods of time, that's exactly what I want. So we now are starting to get into the world of if we can get probe data to us, that really meets our needs. So we've been doing that for a while now, and it's really started this whole continuum. If you think about what it is we need to do, we as an organization need to determine where accidents are happening. Then we need to notify the public so that they don't get involved in that backup, as well as notify police and fire and EMS so they can get out there. We have to detect it, we have to notify it, and then we have to notify the public. We started off doing all three of those things. We put sensors out there to detect it. We then notified the police, fire, EMS, came up with good procedures for how to get them out there. And then we put the big giant overhead message signs out there. Well, as the years have gone on, you're going to see that that's been changing a little bit because government did all three of those roles, not because we were best at all three of them, but we were the only ones that really could do all three of them. Back when the only way to detect what was happening was putting a big, expensive camera on the side of the road, well, really only government can do that. But there's better ways of doing that. If the cars know where they are, if the cars can start letting us know, if the services are out there and they can let us know, that's cheaper, that's better. We can start getting rid of some of that field infrastructure and start buying that data. When it comes to notifying the public, we put the big giant sign over the freeway, but that's 3 lines of text. There's only so much you can say in 3 lines of text. So if there's other ways that are better ways of doing it, the cars now have their own data streams coming in that your own car can tell you what's happening. There are other better ways to do it. So as that technology takes off, I think you're going to see government spending some money to get data about what's happening out there, spending some money to get information out to you so you know about it, and then we're going to concentrate on what we really do best. We run ambulances, we run fire trucks, we run police cars, we do things that you need. So if government can concentrate on what it's really good at, not just the only things that it has the physical capability to do, your money is better spent. So you're going to see a lot of that. Incident management, these are our trucks. We can do a combination of either just a lighter duty truck that can tow vehicles off the road, that can push vehicles off the road, all the way to a fully qualified emergency response unit that can go out there, set up its own cameras, set up its own work zone, and stay for a long period of time. We have approximately 6 to 18 units out there 24 hours a day. Close coordination with state police. We actually do have the ability within Maryland to move things off the road without waiting for people to come in and clear them up. That also used to be an issue, and that was another one of those Governor Schaefer, Mr. Kassoff things, which was back in the day, if you have an 18-wheeler and your truck breaks down, it's blocking the roadway. Our only real choice was to let you call your company sends out another truck, that other truck then you unload from one, load into the other. And there was one time where that happened on I-95 where it happened during the morning rush and it was still there by the evening rush and everybody lost their minds, and rightfully so. We worked with the legislature, we worked with law enforcement, and we passed a clear the road policy that basically says, in the name of public safety, because vehicles stopped on the interstate. You know, people don't think about it, but most interstate accidents are relatively non-fatal. Everyone's going the same direction, so you're gonna have kind of crashes like this or like this, but once you stop traffic, and everyone assumes back in the back that traffic is still going at 80 miles an hour, as soon as they crest that blind hill and traffic is stopped, secondary accidents are way more fatal than the primary accidents. So if we can, in the name of public safety, clear the road more quickly, then it does save lives. So we actually do have permission now that if there's no reasonable time limit for someone to come and clear their equipment, we will push it off the road. And if it destroys all their equipment, they can feel free to file a claim and we'll deal with it later. Traveler information, this is just right now, you see a lot of these signs trying to get information out to the public because that's the easiest way for us to get information to you. It's limited. There's only 3 lines of text. You can only do 2 phases before the federal government feels that we're overwhelming people with too much information. You don't want people trying to read a very complicated message, but it still was the best way to do it at the time. You're going to see a lot of these go away as we start communicating directly with cars. We had these Travelers Advisory radio stations. You've probably seen some of those. They're 1610 AM for the most part. It's unregistered. You don't have to have a special FCC license. You don't have to have the same type of FCC license that you would have to have for a regular radio station. They only broadcast about a 2-mile area. They were good for their day, but I mean, a lot of cars don't have AM radios anymore. So the fact of anybody really using this technology is really, that's starting to go down. So you're going to see those start to go away. But the number of people that use their computers are going up. So you'll see there's a lot of ways we're trying to get information out to you by computer or by telephone. You can also dial 511 and it'll talk to you about what's happening out on the roadway. So as we're trying to do this, get information out to the public, we're trying to find better ways to more quickly get information out. You saw the travel times, that's an automated feature now, so no operator has to type that in. It automatically is provided by the computer system. Toll rates are automatically updated by computer system. Weather messages now. Last year was the first time that we started connecting these signs to our weather stations that we have on the roadway, so that when a weather station in an area shows that the air temperature is less than 32 degrees and the pavement is wet, then it automatically starts putting messages up on signs warning people that icy conditions are possible. So it's not perfect. It's not saying there's definite icy roads exactly where you are, but it is quickly getting word out to you that the situation could be icy, so you can make a good decision. And then as the storm comes in and more people are involved in it, we'll put up more specific messages. But we're trying to figure out how to very quickly get that information out to the public so the public can make reasonable decisions. Traffic management for special events, work zone management, emergency weather event operations, we talked about that. Our system is set up to be able to operate 24/7 on its own power for an extended period of time. So we are definitely set up to try to make sure that we can continue this function whenever we need to. Over the years, we've ended up pushing our system out to 36 different agencies and over 91 operating centers. So we realized that it's not just us that needs this data. So this data is also going out to other people that do what we do. So these are some of our traffic management centers, but the authority has its operation centers, the counties have operation centers, BWI operation centers. So we try to make sure that we push our data and our video out to other like-minded people. Then there's law enforcement. You know, at the end of the day, we are not police officers. We do not have police powers. We don't want police powers, but we do need to work with them because when something happens on the roadway, they're quite often the main ones that need to deal with it. Highway maintenance, our own maintainers have access to all this so that when something crazy happens out there, Back in the day, if something happened on I-70, somebody's going to call us. We're going to call the Dayton shop. The Dayton shop supervisor is going to get in his yellow truck. He's going to then drive up to I-70. He's going to see what's happening. He'll get on his radio. He'll call for help. Well, now when something happens, he logs onto his PC at work. He knows everything we know about it. So he knows about the incident. He knows where it is. He can pull up our video. Then he can send all of his forces without having to go out there. So we're trying to make sure that we have this data to do what we need to do, but we also share it with others. Emergency operations. Emergency operations used to be how the counties deal with tornadoes and hurricanes. That's what the county emergency operations centers used to do. Now they do everything from, mass casualty, mass shooter, mass whatever. So the counties, their responsibilities over the years, especially since 9/11, have really, really picked up. We try to make sure that they have access to the same information we have as well. Information sharing. We have a very good relationship with the University of Maryland. They have a specialized Center for Advanced Transportation Technology, that's designed to do this exact type of thing. All of our data in real time goes down to the University of Maryland, and then they use it to, A, make sure that they've got it available for research for their students, because that's part of what they need to do. B, if they have access to all of our data in real time, as soon as we need a study done, the state university systems in the United States still have a role that they had back in the 1800s when many of them were formed, which is the research arm of state government. So when we need research done, they have all the data as well. So we try to make sure that they get the data in real time, as well as the people that maintain the systems for us. These are the primary systems I wanted to talk about then. So we've got our advanced traffic management system. It was developed in the mid to late 90s. It identifies and tracks those traffic flow disruptions. It sends out first responders. It also notifies the public. It sends notification to the media. It updates the real-time traffic website. So it tries to make sure that it finds out what's going on, sends out first responders, notifies the public. Emergency Operations Reporting System was developed actually before ATMS. It was developed back in the days that we were fighting these big major snowstorms. And as soon as you're fighting the snowstorm, the Secretary of Transportation, the State Highway Administrator all come to the Statewide Operations Center, and the media flock in with them. So when they're standing there, the media really want to know two answers. One is, tell me what you're doing to fight the storm. So they want to know how many trucks do you have out, how many people are on standby, how many contractors are you bringing in, how many roads are closed, how many roads are open. But they also want to know, and how much is this costing us right now? The state of Maryland has a pretty in-depth financial management system. And that financial management system is run out of Annapolis, and it will tell you anything you want to know about state government expenditures, as long as you have about 6 to 9 months before you really need that information, because it takes a while to get through the system and then make its way to Annapolis and get put in the mainframe, and no one's going to wait for that. So EORS is really designed to be that whole, what's happening with the storm, who's doing what counties are in snow emergency, but it also takes a look at all the people that are doing things on the roadway, and it estimates what their cost is. So we can tell them at this point of the storm, it's estimated that it's costing the state of Maryland X dollars, based upon here's how many state people are currently active duty fighting it, here's how many contractors we've brought in, here's how many front end loaders that we have spreading salt, and here's how much salt they're spreading. So it's a tool to have situational awareness, what's happening, and then estimate how much the cost is. And then all of those three systems, those are the three primary systems that my division maintains. And we do all the design, build, operating, and maintaining of those systems. And then there's just a slew of web servers and mapping servers and all the things that allow you to take all of this data and distribute it and display it in some kind of reasonable, usable format. Currently, right now, for those different systems, these are the numbers of lines of codes, and these are all owned by the state of Maryland. These are not commercial off-the-shelf pieces of software. So that's the current number of lines of code total, over 7 million lines of code right now that we are maintaining for those systems. So where does all this money come from? Well, Maryland passed a law years ago stating that if you're going to spend money on something that's major, then it's a major IT development project. If you're going to do that, it's got to be approved and monitored by the State Department of Information Technology, and it's got to be reported to the General Assembly every year. That's smart. You don't want people spending a lot of money without some level of oversight. So to do that, for those three systems that I told you about and the other ones, the capital budget for updating those is about $4.6 million. the money that we have then for O&M, for purchasing new switches, new routers, all that kind of thing, sustaining engineering, it's probably about another $3 to $4 million. So it's less than $10 million a year for all those systems. But what is good systems engineering? And this is what I came to talk about last May. So if you weren't here last May, shame on you, but it's probably still sitting on the internet somewhere. You can go back and take a look at it. At the time, I came out here to talk about what is this good systems engineering. Well, the federal government provides normally about 80% of the funding. So that money that I was telling you about that we spent on this, about 80% of that is federal money that comes in. Only 20% is state money. So we're very financially frugal system when it comes to state dollars that are put into it. But to make the feds happy, they've for years had built into their law that all ITS's intelligent transportation systems, projects that are funded with highway trust funds, shall be based on a good systems engineering analysis. And these are the kinds of things that they think that that should be. But it's up to me to sell them, okay, here's what I'm going to use for my good systems engineering analysis, and it's up to them to say, yes, I agree with that, or no, I don't agree with that. Well, what should it look like? Well, the State Department of Information Technology, they came in and said, okay, well, CHART is one of those major IT development programs, or major IT development projects. So according to the State Finance and Procurement title, it's got to have a executive business sponsor, it's got to have a full-time systems management team, and it's got to use this rigorous systems development life cycle. And if you're ever curious about that, go to the Doit website. They'll tell you exactly what that is, but it looks a lot like this. It's got a lot of, well, let me get to the next slide. So we then, on our side, say, okay, so I've got to prove to the feds we have a good engineering analysis. The state Doit tells us what they think we should do, and they prescribe down to the actual deliverables what this waterfall methodology should look like. So we have a very in-depth system and a way of tracking what we do to show that we're meeting that need. So for the last 10 years or so, we've been following this process. And so there's a schedule. When I came here back in May of last year, our schedule kind of looked like this. So we'd be working on an advanced traffic management system project, and here's what those projects look like. And it's a nice waterfall, so by the time you start this one, you're about halfway done with that one, and then when you start this one, you're about halfway done with that one. It's a very traditional waterfall. It was pretty easy to manage. And to do that, we have all these required quality assurance plans, program management plans, risk management plans, configuration management plans, communications management plans, all the things that y'all have seen over the years when it comes to a waterfall methodology. As soon as we would want to do one of these projects under the contract, then we at the state government would issue a work order to the contractor. We have a 10-year contract right now with CSRA. It's 5 years with a 5-option year part to it. We would issue a work order to them. They would review it, and then they would start doing the things you would think they would do, defining solutions, developing WBS, the skill sets of who they might need. They do all of this, and then they kick it back up to us if there's somebody we need to approve. Then we would look at that person and say, okay, that person meets our needs, that's a good person. And then they finally would take a look at the work order, they'd kick it back, we'd review it, we'd kick it back. But it's what you're used to. It's, okay, we're the government, do this for us. And then we sit like this while they do all the stuff they're going to do. And then they say, here's what we're thinking, what do you think about it? And then they sit like this while we go through all of that. Once again, if your intent is to make sure that you get what you think you're going to get and that everybody is clear about everything that everyone is doing, it's not a bad process. But since I'm here to talk about Agile, I think you're going to find out one of its problems is it's not particularly fast, and it tends to give you one shot at getting it right versus quick and easy early failures while they're small and relatively inoffensive. So it did work. It worked just fine. Then it just basically, you can read this on your own later. It kicks back and forth. It kicks back and forth. So, however, you saw when I was talking earlier that it's not just ATMS anymore. Now EORS is involved, and we've got all this weather information and lane closure information. So we've got more systems. So since that's the case, here is that current month's map. This was from September of this year. So now it looks more like this. So you've got some lane control or lane closure permitting stuff happening up here, some mapping stuff happening down there, You've got some advanced traffic management stuff down here. You've got some EOR stuff in the middle. You've got some web stuff down at the bottom. It's manageable. It's not out of control, but it certainly is not that nice sit back and wait, because now we're all working on so many things at the same time that it was really getting a little confusing. And then if you really get into our schedule and look, you'd realize that this one, it pops up here, which says streaming video player. For those of you at home that do anything with flash video, you probably know that flash video has been a huge security risk for quite a while now. And we've all known that, and we've all been working on what should we do with this flash video security problem. And as we debated, and as we debated, and as we debated, the web browsers finally decided, okay, we're going to do something with it. So suddenly, Internet Explorer stops accepting, they change it. And so you say, okay, I can fix that. And then when you do that, Chrome says, well, we're going to change how we do it. And then when Chrome says that, someone else says that. So now I've got video that I'm providing to other first responders and to the public. And I get a phone call from you, and you say, it's not working on my desk. But he calls and says, well, it is working on my desk because y'all have two different versions of Chrome, and yours works and yours doesn't. So suddenly these external unexpected things started cropping up. Maryland 511, the old contract was going away. We need to figure out what we were going to do with it. So we only had 3 or 4 months that we needed to figure out how to bring it in-house. These things that were started cropping up that we realized are out of our control, and we're going to need a very quick way to respond to, and our old way of doing it just didn't quite meet that. We also found out as we were building these that we were doing a good job, but of those releases, even when it was that nice, easy, calm waterfall, about half of the completed releases still had scope changes. We were not perfect. I'm sorry to really shock all of y'all, but we weren't perfect. There were scope issues. So as we went through these projects, they would have something that either impacted schedule or budget. So we decided about 6 years ago we would start making smaller builds. That's our answer. Well, instead of having bigger builds, there'll be smaller builds. And that helped out some, but even with the smaller builds, the rate of scope change stayed the same. So if the scope changes were not being caused by just the pure size of the build, what was it? So we started looking at moving to Agile. In 2016, I attended a Federal Highway-sponsored webinar. That's actually where I first met Gundars. And I read a proposal that said, Federal Highway agrees that this good systems engineering doesn't have to be traditional waterfall. You could use this thing called Agile. And so the Incose Transportation Working Group was formed, and they started working with Federal Highway of how could we possibly do that. So we started looking into, if we're used to doing this, and this is what the feds and the state and my management expects me to be doing, but I've got all these problems that I now need to fix, could I do it looking more like that? So we started looking into, it's not just ATMS now, it's also EOR's LCP. We need to get away from this waterfall methodology. So beginning right now, work order 17, which was actually in 2010, that's where we started doing those smaller releases. We thought that would do it, but we still were having those scope changes which impacted either schedule or budget. So we knew we needed to move towards something, and Agile was an option. I don't want to put in 100 slides telling you guys what Agile is. So this is my only slide that's actually got Agile buckets of information on it. But just so you do know in general, it's an alternative to traditional project management. It's used in software development. It does help with that unpredictability due to these smaller increments of builds. Not smaller builds completely, but smaller increments within the builds. That each major activity can occur concurrently organized into cycles. It's continuous or frequent small deliveries. It's frequent opportunity by the customer. I needed to have people that I could dedicate to being a part of the design teams. I couldn't just sit back in the back and wait for the design document to show up on my desk, and then I go through the 300-page design document. So I need to have people that are ready to be a part of it, and that these changes in our customer need, that we would be able to integrate those into the next iteration when suddenly Flash is not going to be acceptable anymore or something else crops up that we weren't expecting. The move was really kind of a 3-year effort. So in 2015, we knew something was coming, and so when we were basically had our time that we were going to update our tools that we used for PRs, problem reports, and the tools that we used to keep up with the what the source code was, we started looking into what tools were also Agile friendly. And so we did move to Jira for our PR backlog managing. We went to Confluence for collaboration. And then our source code control, we went to Subversion, all three of which are well organized to support Agile teams. In 2016, we started training. I had to go to my management and say, then if we're really going to do this, we need to go ahead and start putting money into training our people who we have been training for the last 10 years to do this very in-depth waterfall methodology. So we started training our people on certified product owner training as well as general team training. The contractor on their own nickel, because their contract says whatever internal training they need, they pay for themselves. So now we're changing the way to do it. CSRA had to go ahead and come up and absorb the cost of training their own people of the general development team training as well as Scrum Master training. So that all was happening during 2016. And then in 2017, we actually took the final step of trying to figure out if we're going to be doing this very quick, 2-week, buildable bits of code that we're working on, then we need to find a way to make our testing less manual, make our testing more frequent, and a way to do continual regression testing. So we've started coming up with automated tools of how we do those things. So right now, ATMS Release 19, which is starting in December and will end in June of 2018, will be the pilot project. The team for this project is just started estimating the project. Releases, we're going to do 2-week sprints. So every 2 weeks, there will be deployable, fully tested code. We're not going to deploy every 2 weeks. There's nothing in Agile that says you have to deploy every 2 weeks. I would argue that if your intent was to deploy every 2 weeks, depending upon the size of your system and the size of your user base, your users will revolt. If you're trying to teach your users something new every 2 weeks, they won't have finished trying to work the bugs out of what they just learned before you tell them, oh, and now there's something new. But that doesn't negate the value in every 2 weeks having fully built, tested, deployable code. So that's our goal right now. The backlog grooming sessions and sprint review meetings have been conducted. Those are going to be in alternating weeks. Work status is being tracked and reported back on the sprints. Release burn down charts, release burn up charts will be used to track. Each step of the project is subject to the inspect, adapt approach. So we've all gone through the training. This is going to be our goal for doing it. So how's it looking right now? So my first job is easy. Kick off the work order. So here are the things that we think we need. We went ahead and I brought in my certified product owners and I said, okay, what's in the backlog? I can learn all the new language. What's in the backlog? So we looked at what was in the backlog. We pulled out the amount that we thought was probably a reasonable number of sprints to be in a work order, and we kicked that over to the contractor. The contractor then started doing this estimating effort, and a planning poker session started. Keep hitting the wrong button. So planning poker session started where they basically break the backlog items out into individual user cases. So when you do that, the use cases, each team member independently comes up with what they think is the estimate. Will it fit within a sprint? And then they all get together. And where they agree, then that's the correct size. Where they don't agree, they all work together to figure out what that correct size is. And then at the end, they come back to us and say, can we do all of that in the number of sprints that we think is reasonable for a work order? We'd love to be out of the work order business. In a perfect world, Agile would be, give Rick a big pot of money, I bring in the contractor and I say, here's the money for the year, we'll just do the stuff we do. But sadly, government doesn't work that way, and I think most businesses don't work that way either, because remember, the legislature wants to know what we're going to be doing, and they get reported every year on that, and the senior executive sponsor wants to know what we're doing, and he tracks me every other month. So we've got to have some way of bounding what these sprints are going to look like, what we're going to be deploying. And right now what we're doing is we're creating these arbitrary work orders of, let's say it's 6 sprints. So it'll be 6 sprints, then that's how many we'll do in that work order, or maybe it's 12 sprints, or maybe it's 18 sprints. So right now the contractor's looking at it, and then they come back and they submit the work order scope statement back to us for final approval, and then the sprint begins. So like I said, we're getting ready to start this. I wish I could tell you how well it's going to work, but right now, that's the goal. So my job now, I mean, at some point you stop being a computer person. I haven't written code in probably 30 years, and I haven't really done any architecture engineering in probably 15 years. I'm a salesman now. That's what I do. I manage my people, and then I sell to the state government what it is I think I need to do so that they can make sure that they fund me properly, and then I sell them at how well we're doing it. So yes, I have become a salesman. So the requirements of the state's very strict software development lifecycle is right here. So there will be a software requirements document. There will be a design document, systems architecture, test master plan, integration test procedure, system test report, user guide, O&M guide, application disaster recovery plan, training plan, and implementation plan. So I'm sure you all have heard of all those things, you know, back in your systems engineering lives. Well, now that we're doing Agile, software requirements. Okay, software requirements. That's not too hard because we're going to have all these user use cases, all these user stories. So if we can get the user stories use cases together with some kind of acceptance criteria, then at the very beginning of the work order, we can put, even if it's going to be a dozen sprints for the work order, we can put all of those together because that's that team that got together and went through those when they were doing their initial estimating. So we feel pretty good about that. Design document. Well, the design document in the past used to be a couple of months into this work effort, we get that 300-page detailed design document. Then we read the detailed design document, we get back to the contractor, they take our changes, and we go ahead and we do it. Well, that's not going to work with Agile. That's not how it works. So I'm just going to have to go in and say, I know that the current law, the way it's written, requires this. Here's what we're going to do. We're going to focus on the as-delivered state, and it's going to be delivered at the end of the work order. So you'll get your design document, and the design document's going to be, here's what we built, and it's delivered at the end of the work order. Okay, well, isn't that kind of risky? Well, yes and no. If I've got my own product owners that work for me that are on these teams, and every 2 weeks at the end of the sprint, they have to demonstrate to us that what they did works, then no, it's not that risky because every 2 weeks we're keeping up with it. It's just I'm not going to have a 300-page document that I could hand to an auditor ahead of time and say, here's exactly what we're going to do. And hey, if you back up a handful of slides, you'll see back in the past when we used to do that, over half of those things ended up with scope changes that impacted budget and impacted schedule. So even when you had that 300-page document, was it really what you needed to ensure that you're going to get exactly what you wanted? It really honestly never was. But I've got to be a good salesman. And if I'm here next year to give you another presentation, you'll know that I was a good salesman. So I don't have to go over all these, but like systems architecture delivered at the end of the work now. Test master plan, we're going to replace with these program level document that says, in the future, rather than each work order having its own test master plan, we're going to have, here's how we test. Here's our automated testing tools. Here's how those tools do what they do. And then for each individual work order, for the integration test plan, the system test procedures, every 2 weeks there's a demonstration. That demonstration will be documented. That is our test plan. It's not going to be that 200-page test plan of you will do this, it will check. You will do this, it will turn green. You will do this, it will print this out. We're not going to have that anymore. User guides, the rest of the stuff we're going to keep and put the same kind of money into it we used to put into it. We also have a bunch of meetings, and these meetings will make sense to those of you that were also in this world. So we have a change control board. We have architecture working group meetings. We have PRB meetings, problem report board. We have JAD sessions. We have lessons learned. We have a configuration change board, which has release content reviews, ORRs, RDRs. I won't read this whole slide to you, but in general, what we're going to try to do is if we're going to keep a meeting because it made sense, we'll say where it fits in Agile. So just one example then, if instead of a separate architecture working group, that architecture working group which would come up with requirements that need to be done, it's now going to be done in that documented by the very beginning of those backlog reviews. So we're going to still be doing things, but I'm going to have to come up with some kind of a document that explains here's what we used to call it and what it did, here's what we call it now and what it does, and here's why. So that's kind of the Agile presentation. The last 5 minutes was just meant to tell you, okay, and what things are we going to be building in this Agile-y way? Some of the things I talked about last year are still true. As we build these systems out, we still need more flexible software modules, integrated networks, because the subsystems are growing, the number of systems are growing, the number of places that use the software are growing. So you need to see things like high-speed connectivity to real-time backup site. We can't afford to have the 2 to 3 hours to fail over like we used to have. We're trying to eliminate our copper circuits because copper circuits are not only expensive, they're hard to run to the side of the road when you tell Verizon, I want a T1 here, and they say, what's the address? And we say, it's right here on the side of I-95. And they say, well, what's the address? And we say, there is no address. And they say, well, we won't run a thing, so we make up addresses. It's 27 I-95 North, but it's right here. That's hard. And not only is that hard, we dig them up faster than we put them in. We at State Highway, what do? We design roads, we build roads. As we build roads, what do? We tear things up. So we've been moving away from copper circuits to more wireless where we can. Sometimes it's an APN across an existing wireless network. Sometimes it's our own wireless network. There's a new thing called FirstNet, which is being designed just for first responders to have their own wireless networks. It's going to be pretty cool. Fewer physical devices, more mobile devices, mobile cameras, mobile dynamic message signs, things that are not stuck in one place. Talking to other people, integration with central authentication, things that kind of make the systems easier to use, and then we've got to make the systems smarter. State positions are shrinking. We're getting fewer and fewer state employees. I mean, at the end of the day, you can't get past the fact that if you want to cut the state budget, cutting state employees is a fairly common way to do that because there's a lot of us. So we're having more and more contractors on board. And as we get more and more contractors on board, we suddenly don't have somebody who's been there for 40 years who was there when Hal Kassoff figured out how to do this and knows exactly how to do it. So if the person doesn't have that kind of experience, who does? The computer systems. So we're building artificial intelligence into them as best we can for decision support so that when there's an incident, you know how we automatically put those weather messages up. You're going to see us automatically putting a lot of new types of messages up in the future. State data, well, I told you, mixing our own data with that probe-based data. Multiple sources for better real-time queue estimation so that we not only tell you that the roads are blocked, but we tell you it's a 3-mile backup, or we tell you it's only a 1-mile backup. See how I can say only a 1-mile backup like that's not a big deal. So maybe I'm getting a little bit jaded in my old age. These are some of the exciting things you've probably heard about. Governor Hogan and Secretary Ron came out a couple of years ago. Actually, the Secretary, when he came in, he asked us a reasonable question. He said, what's your worst problem in the state of Maryland from a transportation perspective? And the honest answer was I-270. I-270 is just, it's insane. There's just no way to get up and down I-270 during either rush hour. And he says, okay, then I'm going to help you fix that. What's your plan? Remember, we design, we build, we operate roadways. So when he asked that, we said, oh, thank God you asked, come with us. So he came in and we showed him the room full of filing cabinets and we slid them out and we said, here is the $300 million 20-year plan that would fix that problem. And we kind of expect him to do what a lot of previous secretaries have done, which is, well, that's not possible. I can't get that. It needs to be, if the problem is so big, sometimes the solution becomes do nothing or do very minimal. Secretary Ron is not that kind of guy. Secretary Ron has been an interesting guy to work for. He's like, okay, well then what can we do? So he actually went out to he said, okay, I now know what my DOT wants to do. He went out to enterprise. He went out to the companies out there and said, what do y'all think we should do? We want all of y'all to propose, it's $100 million. I'll tell you now, the project is $100 million. For $100 million, what could you do? And each company proposed what they could do for $100 million. And he chose the one that would move the most people the fastest, that would make the biggest difference. So there is a project now that is ongoing on I-270, and it's going down to basically to the, from the 270 split to 370. It's going to be a progressive design build approach. It's not, we don't know exactly what they're going to do. We know high level what they're going to do. It's going to maximize vehicle throughput, minimize travel times. It's all about safety. So the things that they are talking about are ramp metering. For those of you who have ever traveled up in Chicago, some other places, California, before you get on the interstate, there's a traffic signal. And then it turns green, and 2 cars go, and it turns red, and everybody else stays on the ramp. And then it's monitoring traffic upstream and downstream. And then when there's a spot, it then turns green, and 3 more cars get on, and then it turns red. So we've looked at that in Maryland over the years, and we've always kind of just came back with, well, it's just not a good fit for us. Well, this company thought so. It actually fit in well, and so now it's a good fit for us. We'll be installing ramp metering. We're going to have something called an active traffic management system. This active traffic management system is going to have speed sensors, traffic flow sensors, cameras. It's going to have dynamic message signs, and for the first time ever, you're going to see on I-270 variable speed limits. So when it detects that there's a problem up ahead, we'll still do what we've always done. If there's an accident, we're going to respond to it, and we'll put a message up on a sign telling you there's an accident. But before that happens, what you're going to see is, as traffic slows down, automatically a message will pop up on a sign that says, congested area 2 miles ahead, prepare to slow, and a variable speed limit sign is going to go from 55 down to 45. Now, there's been discussion, is that an enforceable speed limit sign, or is that an advisory speed limit sign? Right now, they're saying it's an advisory speed limit sign. But for the first time, I talked about traffic management. We're going to try to give the drivers enough information that they can make intelligent decisions. So it's going to tell you not only use caution, but you should slow down to 45 miles an hour. And then when you get to the next level of signs, 25 miles an hour. And then the next level of signs, 15 miles an hour. So active traffic management. So you're going to see that on I-270 as well. I-95 active traffic management project. The I-95 is a big issue. This project right here is basically between Maryland 198, down by the Capitol Beltway, all the way up to 895, almost to the Baltimore Beltway. We can't build an awful lot more of lane miles there, so we're going to start looking into, can we actually put traffic on the shoulders? You've probably seen this in Virginia. Virginia does it quite often. So there'll be red X's when you're not supposed to be on the shoulder, green arrows when you are on the shoulder. The traffic engineers in us love it. That's an awful lot of space you're not using just to be a shoulder. The incident responders in us hate it, because that shoulder is where we move traffic that's having problems right now, and if it's currently a travel lane, where do you move traffic that's having problems? Not an insurmountable problem, but once again, Secretary Ron, Governor Hogan say, find a way to make it happen. So this one is also on the books. This is probably the one you heard. I've got to tell you that when this came out, everybody in my office, you saw the heads start popping up over the cubicles like groundhogs, because this was kept pretty quiet. None of us knew this was coming, at least at my level and lower, and we're watching the governor on, oh, look, the governor's on television. Somebody turned that up. Well, they decided that we are going to go ahead. Remember that thing I told you that nobody could ever do because it's just too big and it costs too much money? Apparently, that only lasted the first couple of years of Governor Hogan's time in office, because he came out and said, you know what, if it's $9 billion, it's $9 billion, but we are going to go ahead and add new lanes to the Capitol Beltway. We're going to add new lanes to I-270, and we are going to take over the Baltimore-Washington Parkway. We're going to take it from the federal government, and we're going to bring it up to federal interstate standards, and we're going to add lanes to that as well. So this is going to be the largest public-private partnership in North America that we've ever seen. It's going to reduce congestion for the driver, significantly improve traffic conditions, but it is going to be an amazing bear. And then, of course, we're also preparing for connected and automated vehicles. I told you that earlier, that when it comes to these types of vehicles, the smarts in the vehicles are coming whether we want them to or not. And the neat thing was, I talked about it last time I was here. I don't want to spend too much time on it today. The neat thing is, when government drags its feet, it's not just connected vehicles, but it's vehicles talking to each other, not just for us. And the vehicle manufacturers don't need us for that. So they're already creating ways for the vehicles to talk to each other, so that theoretically your car knows that it's stopping. It tells his car, which tells his car, which tells his car. So even he's a half mile back, he now knows that traffic has stopped up ahead of him because the car has passed it from one car to the next. That's being worked on right now. But we want to also work on the way to get vehicle to infrastructure. And that infrastructure is going to be something we have to maintain. That's how we get information out to your cars about what's happening on the roadways, that type of thing. We've got actual groups that are meeting and are now working on what this is going to look like for the state of Maryland. And then to make all that happen, there's going to be a technology corridor on US 1. So US 1 is where we're going to build a test bed. So we're going to try to put as much of this technology as we can along that test bed, so that we can determine how well it works, how well these new updated signal controllers work, how well these dedicated short-range communications radios work that talk to the cars. We're going to install all this as we can. Now, everything I'm telling you for all those projects have new things that I'm going to have to deal with. Currently, there's no ramp meters in Maryland. Currently, there's no active traffic management in Maryland. Currently, there's none of this technology in Maryland. So all of this, I told you that at the beginning of that crazy schedule, there were 2 or 3 things out of our control. I've got to get ready for the next several years to flip-flop that, where there's going to be 2 or 3 things that I knew about, and all the rest of it is outside of my control. So Agile is a requirement for me. I've got to be able to say, I know that government is built in a way that moves ponderously and slowly, and that's not always bad. It keeps us from making bad decisions sometimes. But we can't do that anymore, at least not in my world. So that is the reason why that we have bitten the bullet, and we are now moving towards this Agile methodology.
Okay.
I know that was a lot.
Now we're ready for questions. I ask you to get a microphone. I do want to make one comment about Agile first. I think that the definition of Agile is when you don't know what the requirements are and you're developing the requirements as you go, is really the way that I sense that Agile is defined and used. You have incremental, and incremental, you know all the requirements ahead, but you just execute in increments. But with Agile, you're dynamically executing it as you go.
And it gives you multiple shots at it. You don't have that one chance to get it right with lots of documentation that is now wrong.
Well,
so
you can also go off to the wrong path and then come back and go back to the other V in the road,
yep.
Which is hard to do if you've got it all wired ahead of time.
Absolutely.
Any questions now?
Yes, sir.
Yeah, a couple of things. One thing, Route 50, Severn River Bridge, if you have a variable speed limits, there's much less margin for lateral movement when you're making more lanes in a given width. And, there have been a lot of complaints in the Annapolis Capitol. So if people were told to slow down from 55 to 50 or 40, you have wide trucks. This is at least during the rush hour period, congested period, and might be a good place. The other thing, in north of Boston, years ago on 95, if there was an accident up towards New Hampshire, they were allowing people to drive in the breakdown lane. Well, they didn't have signs in the 70s or 80s.
Sure.
But that was kind of a practical thing. And the other thing, why in, say, Route 50 going into D.C. from Bowie, they have 24-hour HOV lanes, while many of the other states just have it during the rush hour.
I can talk some about the first 2 subjects, if I can remember the first 2 questions. When it comes to the Severn River Bridge, I can tell you in the Annapolis area, this is way outside of my area of responsibility. I'm not a civil engineer, I'm not the chief engineer of Maryland, but I can tell you that that one area is talked about in meetings that I go to more than any other part of Annapolis, and they are discussing things like lane width, because the engineers will tell you if we can make the lane smaller, we can get more traffic in there, and then the human people will tell you, but the drivers are not doing a very good job in the amount of space they have right now. They are talking about, are there ways of changing the lanes so that, I don't know if you ever noticed on the Bay Bridge, if they need to get more traffic across it, then instead of going both this way and all this way, they'll put one contraflow going the direction they want to go. There's some discussions about that. So they're looking at as many different options as they can, because that is that one area at Severn River that breaks down more than anywhere else in that whole region. So we are looking into that. As far as the breakdown lane, using these dynamic message signs, these red arrows and red X's and green arrows, that's going to be our first shot at that. And if it works well, anything we do, you're going to see in a lot of additional places. And as far as the HOV status of Route 50, I really don't know why it's 24 hours a day. If you'd like, I can ask and get back to you, but I do hear what you're saying.
Yeah, a couple of other things. Well, the IEEE has their ITS journal, that's very thick. There's a lot of foreign authors in that, quite a few as usual. And the other thing, we have the autonomous vehicles, intelligent transportation systems coming back. But one thing in the human factors side, and I noticed this 20 years ago in Houston, when you're, and it has to do with standards, but when you're driving in the morning and you're sort of facing the sun, and you have a white on green sign, it's very hard, even above the road, it's very hard. You're talking about contrast washout or
Sure.
desensitization. And I know in some cases where they have signals, whatever, they have a very, if something else like a very bright white flashing signal to notice something contrast. But that kind of a road sign issue can be a problem, at dawn or dusk when the sun is low.
I can tell you that I've worked for Colorado DOT, Texas DOT, and Maryland DOT. And Maryland DOT is involved in more of the IEEE, SAE, AASHTO subcommittees than any other state I've worked for. So I can tell you that we have the right engineering people engaged in those conversations. Yes, sir.
This thing working? With all this information you're putting out there, all the signage, all this control and things like that, I'm wondering, do you have any legal liability for what you're putting out there? Like and how do you deal with that?
In the world of civil engineering, there's something called the Manual for Uniform Traffic Control Devices, and it's approved by AASHTO in all the states that say if you're going to put any kind of a sign on the side of the road, if you wonder why all the signs look the same state to state to state, that's why. The AASHTO creates these committees that go out and come up with the way things should look, and then they create it and put it in this manual. ITS devices, the big overhead dynamic mesh signs, didn't used to be part of that because we were not considered regulatory, we were just considered advisory. We are now a part of that. So not only are we held liable for what we have up there, we're also held liable for how much of it is up there, how long does it flash between the next phase, how many phases are allowed. There's all kinds of human factoring engineering that goes into that, but it is very clearly detailed in that document. I'm sure we get sued all the time.
Just interested in what kind of architecture tools you're using and whether you use or do model-based system engineering as you develop your deliveries.
No, but only because when Maryland decided that we needed to have good process, the Maryland Department of Information Technology was given regulatory authority to make sure we followed whatever process they came up with. And so they came up with that very manual systems or software development lifecycle. So the documents that we created were actually given to us in a book that said they will look just like this. So we just took what they gave us and we've put the time and the hours into putting all of our words into those documents and make them look like that. That's going to change now. I mean, it has to change now. So Doit has said we can go Agile. They prefer we go Agile, but they haven't changed any of the written rules that say we must follow all the old artifacts from the old SDLC. They're going to, but they haven't yet. So there are going to be some tools that come out, and those tools are supposedly going to help us go down that road, but I don't know what they're going to be yet.
Okay, well, thank you for...
We can't afford to wait, though. So
one more question.
And by the way, I'm not going anywhere, so afterwards, if anybody has any questions, I'll stay here till the last question's asked.
It's a question, if I'm on a road, I'll open up Google Maps. And it tells
well, hopefully
me,
your co-pilot will do that. But
true.
Okay.
And I have a little handy thing over there they use too, right? But it's reading data, it's telling me accidents, speeds. Do you guys, like on the state, is that data you have access to? Are you using their data, or are they using your data, or are you guys totally independent and therefore duplicating data, all the sensors? Is there a relationship there between?
There is, absolutely there is. One of the things we decided in Maryland a long time ago was whatever we had, we would make available to anyone that wanted it. As a matter of fact, when I first got here, I came here from Texas, and in Texas, I was the first systems administrator for San Antonio, which was one of the first major systems in the country. And when I came here, I thought, well, why should we rebuild that here? Let me just get what they built and bring it here. And so I went and talked with Texas, and this was the mid-90s. They weren't ready to deal with the liability of me using their software. And so the other big player in the world was Georgia. So I went to Georgia, and Georgia said I could use their software, but they were not going to charge me for it, but they might charge me some unknown amount in the future that I would have to agree to right now. So none of that really worked out for me to build a system that I thought would be what we needed to be our real, honest-to-God command and control system. So yeah, in Maryland, we went ahead and we rebuilt what we wanted from scratch, but we decided on day one, whatever we built, for starters, would be available for anyone that wanted it. So all the design documents, all the source code has been available to anyone that's wanted it since we built it. And several states have reused quite a bit of our software as they went down the same road itself. We did the same thing with the data. When I first started building the system, the administrator would come to me and say, you know, we're not the police. We need to make sure this makes its way out to the Maryland State Police. So put one of these chart workstations in the state police barracks. Well, I mean, I'm an IT guy. If you tell me I have to do something, I'll do it. It may not be a great decision. So it's like, okay, if you're the state police and you need my data, what I'm going to do is I'm going to knock a hole in my firewall. I'm going to put a T1. I'm going to run it out to your facility. I'm going to take one of my workstations. I'm going to pop it in your facility and basically extend my network to your facility for that one PC that you don't use that often. You forget how to log in. You know, bad idea, but bad sharing is better than no sharing at all. So early on, we realized, you know, if we could provide all the data, then they could pull it into whatever system they have. Operationally, it's a better idea because they're going to use their system every day. They're going to use my system once every 2 weeks whenever it's, you know, they want to do it. So we've always made our data available as well. It's also available to the public. So anybody who wants to get my data, they can, if you go to my website, if you go to md511.org, there's an XML schema and an RSS schema that if you have your own website, you can pull 95% of my data, including the live messages from the signs, the live incident information, and the live streaming video, and put it in your own system if you want to. If you're more of a system, like I'm a system, then there's a way that you can communicate with me where we have a relationship and have tokens back and forth, and then you can ask me for information and I'll pass it to you. We've had that for over 10 years now. So when Google Maps became a thing, we contacted them and said, if you want our data in real time on your map, here's how you can come and get it. They want our data, guys. Waze, everyone says, Waze is going to put you out of business. No, I love Waze. Waze is great. What I love about Waze is it's got all these people out there that are all working together. But the bad problem with Waze is there's all these idiots out there that really don't know where they are and what they're doing, but they're all putting data into the system. So Waze, their biggest concern is not knowing where the accidents are. They've got all of us idiots out there. What their concern is, when's that accident over? Because you're going to come up on it, you're going to put it in the system because you see it, and then when you get past it, you're done. You're not going to go back and say, oh, wait, I need to clear that incident because it's cleared now. We know we have reliable data. That's what they love about government data. So for years, our data has gone to Google, and our data went to Waze, and then Google bought Waze, so they were kind of together anyway. We looked at pulling their data into us, and we have the ability to do it, but up till now, I guess this is an advantage. It's also a disadvantage. Maryland is a very small state with way too many people in it. So every study that we've ever done tells us that the time frame between an incident happening and somebody calling 911 or Pound 77 or one of our own forces seeing it is seconds to maybe minutes. So getting slightly faster data would be helpful, but if that slightly faster data that comes in is 1,000 data points within a mile, a human can look at that and say, oh, I need to look into this and see what it is. But my computer system, if I got those 1,000 data points, now all of my exports are sending out those 1,000 data points as guaranteed Maryland state data. This is something we can believe. My God, there's 1,000 incidents out there. So we tend to not pull in things like Waze and Google Maps that are crowdsourced, but we absolutely push everything we have out to them. If you want to use Waze, if you want to use Google Maps, when I go home, do you know what I use? I use Google Maps. You know, why not? It's a great system. So we definitely make sure that we put the data out there for anyone that wants to reuse it and any company that wants to reuse it. And we've got the ability to pull in external data, but we tend to pull in things like CAD data from other first responders, from state police, from other verified sources of information that we can now respond to. It tends to be what we pull in. Yes, sir.
As you do your software updates through Agile, how are you continually updating it for cyber attacks and security?
Well, if I told you that, I'd have to kill. No, I won't say that. The good news about how we're set up for security is if you're going to set up for security, you really need 3 types of security. You need to make sure that you've got application level security that keeps the right people in the right places of your applications, and we've done a very good job of that. You need to have a moat built around you of ways of detecting any kind of external intrusion that you're not expecting. And the Maryland Department of Transportation does an amazing job of that for a state agency. You should be proud of Maryland Department of Transportation and the money they put into that. The third level has to do with trusted people inside the network. That's an area where we could use some work, and we've identified some things that we need to do. So we are definitely putting the money and effort that we should into security. The only thing that bothers me right now is I've had to stand up in front of very scary high-level people and say, I'm here to talk about the time when we're going to be hacked, not how to stop us from ever being hacked. We're going to be hacked. There is no way for me to keep all the bad actors in Korea and China and all the others out there from ever getting into our system. So we've got those, I said 3 layers and I only told you 2 of them. So we've got that, the good moat, and we've got the good application layer. The third thing that we need to have in place is the ability to make sure that once we are hacked, we can identify it and we can localize the damage that it can do. An example of that would be, oh, you guys have probably all read it at one point. Somebody puts zombies ahead on a dynamic message sign somewhere. That used to be the big thing. Now it tends to be things about our president, but people go out and they hack into the signs. If that happens, 100% of the time in Maryland that's happened, it's because somebody, normally a college student, has gone out to the sign, cut the lock off the sign, get into the sign, disconnect it from my network, and then find a way to put a message on it. Well, if I can't communicate with it, then there's nothing I can do about that other than notify somebody I've lost communications with it, and then somebody goes out to try to find out why I lost communications with it. But within our system, if somebody ever hacks into our system and manually changes a sign by hacking into my system, the system has a lot of robots that run in the background that look for constantly what should the status be? What is this current state of all the different systems out there? So it knows what the message should be on every sign. If somebody finds a way to sneak into that sign and change the message, the very next time we poll it, the system's going to say, that's not the right message, and change it back. So the 3 layers of the moat we're excellent at, the application layer security we're very good at, but the knowing what the current state is and keeping that current state constant across the entire physical state of Maryland, we do a very good job of. But it does worry me because I'll never be able to keep up with the people that are in that world, and I can't pay for that level of people to do it. So it keeps me up a little bit. Yes, sir.
You've indicated that your systems are going to go away from being connected by copper. So that means you're going to use the use of the RF spectrum. What are the problems and challenges of getting the right spectrum allocations and the right frequency assignments, given the proliferation of all kinds of uses of the spectrum these days?
Our experience that we've had so far for wireless, our largest experience has been through cellular. And the good news about cellular is the same as the good news about copper. It's ubiquitous. It's everywhere. And we've been able to do things to help make it a little more secure. Like you can do something called an APN, where we connect to AT&T's network through our firewall, and then it tunnels to the far end so that my IP addresses go to the far end, so that even other AT&T traffic can't decode what I'm doing because it's on my network going through their wireless. That is an excellent, quick, easy way to do it, but it's far from overall secure. And it's also got an issue with the fact that if something crazy major happens and everyone gets on their cell phone, I've got no particular priority over anybody else. So the easiest way to do it is cellular. We're doing it today. It's got issues with guaranteed availability. To get guaranteed availability, there's 2 ways that we're working right now, both of which are federally funded and federally approved. One is called dedicated short-range communications. It's in the Wi-Fi spectrum. It's dedicated just to us in transportation, and it's designed for, I've got an antenna on the side of the road, your car is passing by, my antenna and your car talk to each other while they're close enough, and then your car moves on. That's been approved. It's been approved for years. We're just now on that US 1 corridor going to be deploying some of the DSRC. The third thing was what I mentioned earlier, which is that FirstNet. FirstNet is a major digital wireless network that the federal government approved for first responders. So that's not just transportation, that's also police, fire, EMS. But it is a major nationwide digital radio network, and the states were allowed to opt in or opt out early on, and this was back in the previous governor. He was in love with the idea, so Maryland opted in very early to the point that we now have a contract with AT&T, I think, to provide that in the state of Maryland. So there's going to be a secure wireless RF, some frequency that I don't even know, that is going to be controlled by government in the state of Maryland. So that'll probably be the third area we go towards.
All right, I think we've got enough questions here.
I'll hang around afterwards if anybody has any other questions.
So we got a raffle for the book.
Okay. This book, if any of y'all remember last year I brought a book from Phil Tarnoff, who's a local engineer, ran his own local company. Sir?
We have them all here. I got them from the back. Go ahead.
Okay.
Don't worry
Well,
about it.
I'll get to the overall story is that was written by an engineer, and it was about the transportation infrastructure of the United States. This is his next book. It's fiction. It's written along the lines of a Tom Clancy novel.